pH and pOH. That's what we're talking about, the relationship. Okay, if you read our slides or our presentation on acids and bases, we said a strong acid or a strong base completely ionizes in water. So we're talking about 100% ionization here, complete dissociation. So an example will be, let's say this HC. If it completely ionizes in solution, okay, we'll have this aqueous plus C. Okay, complete dissociation. Likewise, if we have a base COH, let's call that our base. Okay, if it completely dissociates, okay, we'll have C plus hydroxide ions, right? Good. Okay, but then we need a scale that can tell us at a glance how acidic or basic a solution is. So that is where pH comes in. So our pH is a scale used to measure the acidity or alkalinity of a substance, and is graded from 0 to 14. So it's graded, we say, from 0 to 14. Okay, and at the midpoint we have the neutral. Okay, so at the midpoint, which is 7, that's halfway, we have the neutral. Good. So neutral solutions that have this pH around 7 will be solutions like, let's say, water, blood, okay, etc. That said, so how do we calculate pH? Don't forget, if our pH tends towards 14, the solution is more basic or more alkaline, and if it tends towards 0, it's more acidic. Okay, and this is basic. Good. So how do we calculate this pH? Okay, how do we calculate pH? There's a formula for it, and that's pH is equals to negative log concentration of hydrogen ions. Okay, but if we're talking about bases, we don't use hydrogen ions, right? We're talking about bases, we use hydroxide ions. Okay, so in that case, we talk in terms of the pOH. Okay, and that will be negative log concentration of hydroxide ions. Okay, you understand so far? But we still have to relate our value of this pOH. We still have to relate our value. If we're discussing bases, we're using pOH, so we still have to relate this pOH to the pH scale. Okay, to this pH, we still have to relate it to pH. Okay, because the pH is our standard scale to measure acidity and alkalinity. So a relationship exists, and that relationship is pH plus pOH is equal to 14. Good. So this is the relationship that exists. This is the relationship between pH and pOH. So for basic solutions, if we calculate pOH, when we're dealing with basic solutions, if we calculate pOH, we can use this relation, here to calculate the pH of the solution, and so therefore we can know how acidic the solution is or how basic that solution is. So let's take an example to buttress our points. To erase this. Good. All right, so let's take an example. Say what is the pH of what's the pH of, say, 0.1 molar solution of HCl, hydrogen chloride. All right, so we can say that this is an acid, so we'll be discussing in terms of pH, so we'll be using this formula here. So our pH will be, so the pH, we are asked what's the pH, so the pH will be simply negative log our concentration, okay, negative log times the concentration, so have negative log 0.1, and that is, then we'll get 1.0, right? That's very acidic solution. So our pH is 1.0, and we said if the pH tends towards 0, the more acidic it is. So a pH of 1 is very acidic. So what if the question is, what's the pH of 0.1 molar solution of, let's say, not HCl now, let's say sodium hydroxide? Good. What's the pH of 0.1 molar solution of sodium hydroxide? So we use, in that case, we'll write this. Okay, that case, this one will have, so the pOH will be negative log the concentration of the hydroxide concentration, because since we're dealing with base, so we expect that as the concentration given here is hydroxide concentration, so that will be minus 0.1, then we'll still get 1.0. Then we relate this to our relation, the equation we gave. We said pH plus pOH is equal to 14, right? So we're going to relate it. This is the pOH we got, so we're going to relate it to this equation. Let's do that. So our pH will be equal to, if this goes over to the right hand side, it becomes negative, so 14 minus pOH. So our pH becomes 14 minus 1, 13. Good. So we can say that this solution is a very strong base, okay, at 13. That's very strong. So the alkalinity of this solution is very high. So that is the relation. That is how you solve pH problems involving pH, whether you're giving a basic solution or you're giving an acidic solution.